Right, so annoyingly, the very first part of this video didn't record, so I've had to go redo this, just the start of it, and just explain what's going on. So, chain rule is the only thing that I think warrants audio explanation. You'll see from the rest of the video there's product rule and quotient rule on it, and then we'll obviously cover some leavings or questions, so you can see how these rules are applied. But what I was saying at the start was, what's in this pink box? It says evaluate both the inner and the outer function, and then multiply all by the derivative of the inner function, and that's all the chain rule is. So if we're taking a look at this first question here, if it helps at the start, rewrite it in two different colors. So the very first part, what happens when you choose a value for x? So if you choose x is equal to 1, 2, 3 or 4, whatever it is, it's going to get plugged in right here. So the very first thing that happens is it gets put to the power of 5, then you multiply by -3, and then you add 1 to whatever that is. So that's the first thing denoted by inside this brackets. The second thing, whatever this is equal to, you cube it. So that's the second function. So we can rewrite this as whatever's on the inside cubed, and then the inside is -3x to the 5 plus 1. So as that box says, we're going to evaluate both the inner and the outer function, and then multiply everything by the derivative of the inner function. So first of all, we're going to find the derivative of the brackets. Well, if you just imagine what's inside this is just x. So if this was x cubed, you just go x cubed goes to 3x squared. Same rules apply. We just leave, or we imagine that these brackets are the x. So the 3 comes to the front, and then it's just squared because you just subtract 1 from the 3. That's the power. Then we leave everything in the middle. And now we find the derivative of what's inside the brackets. So if we take -3x to the 5 plus 1, and we find the derivative of that, well, it's just going to be -15x to the 4. So we can just multiply this by -15x to the 4. And if we multiply that out, we're going to get -45x to the 4 multiplied by -3x to the 5 plus 1 squared. So that right there is going to be our answer. The only time trig gets a little funky, the only time the chain rule and calculus gets a little funky is when you're using the trig function, which I'll show you in the next question. It's a little bit more of a complicated question because you're dealing with tan. Just be aware, whenever you see trig, just keep taking a look back to your tables. It'll tell you what happens when you differentiate sine, cos and tan. There's some other derivatives in there you won't ever need for the leaving cert as well, which we'll talk about. But then also be aware of what's on the trig page, which I'll be showing you. So it'll show you what you get if you plug in different values of pi or just regular degrees into a trig function. So it'll cover 0, 45, 90, 180, 360, something like that. So it'll just be all the different fractions of 360 degrees or radians. That'll get you there, but it's just knowing to keep taking a look back and see if you can make the question easier, which I'll show you later on. It looks like it gets more complicated, which I'm going to be showing you now in a second, but it collapses down at the very end to just be a really simple answer. So just trust what you're doing, same steps every single time. So even though it might look a little funky, just trust yourself. You'll know if you're completely going wrong once you get a lot of practice in. But yeah, so if you can see here, here's a trig function that involves a chain rule. So it says the function g of x is defined as follows for x being a real number between 0 and pi. So x is just going to be some number between 0, it has to be bigger than 0, and less than pi, so 3.1415, yada yada yada, keeps going. Not overly necessary though. So how do we differentiate this? Well, g of x, as it says up there, there's two things going on here. First of all, we have the tan, and then I'll change the colour, of x over 2. And then this gets multiplied, I'll change to green, the natural log of x. So how do we do this? Well, if you look at this, the first thing you realise is that it's one function times another function. So we're going to use the product rule. What is the product rule? Well, the product rule is u dv plus v du. So that's what we need to figure out. If we find that, we're going to have u is equal to another colour, u and v. I'm just using different colours so you can follow it step by step. So the u part is equal to the tan of x over 2. Well, how do we differentiate this, first of all? Well, the tan of x over 2, as you can see, there's two things going on. The very first thing is whatever we choose for x, it gets divided by 2. And then whatever that number is, it gets plugged into the tan function. So this is actually chain rule straight away. How do we differentiate this? Well, we're going to have to take, I'll go down here. We have the tan of x over 2. Just like before, we're going to differentiate the outer function and then multiply it by the derivative of the inner function. So, what's the derivative of x over 2? Well, x over 2 just goes to a half. And you can see that has, if you write x over 2 as a half times x, anything where you just have x with no pairs that it's just itself, that x disappears, so it just goes to a half. And then the derivative of tan, well, that's sec squared. So tan of x over 2, I'm going to just bracket that off, goes to the half, because this is what we get from this part here and here, multiplied by what tan is, or the derivative of tan, which is sec squared, and then the inner function stays the same, x divided by 2. So we know that u is equal to tan of x over 2 du is equal to a half sec squared x over 2. You don't need to remember that. It's useful if you do, so there's less thinking in your actual leavings there, but it is in your tables, which I'll show you now. So here, when you go to page 25 of your tables, you can see right here, the tan of x, when you find the derivative of it, goes to sec squared. Chain rules here, but it doesn't really make a lot of sense if you don't read a lot of maths or haven't seen much of this before. But this is literally just saying the derivative of the inner function gets multiplied by the derivative of the outer function, and then you leave the inner function in there. But again, it doesn't really make sense, but we'll see it more. So that's our du. Then I have my v, which is the natural log of x. What's the derivative of the natural log? Well, it's 1 over x. Again, it's in your tables. If you go here, you can see the natural log of x just goes to 1 over x. So now we just start filling out the product rule. So we have u dv plus v du. So what's my, so u is the tan of x over 2. We multiply that by dv. Well, my dv is 1 over x. And we add on v, which is the natural log of x. And then we multiply that by du, which is the complicated looking one, which is a half sec squared of x over 2. So we don't really need to do much now, because what the second part of this question said is find the value of g prime of 2. So this is what g prime is equal to. Now we need to figure out what happens when we plug pi over 2 into it. So let me just move this up here, just so I can give myself a little bit more space, and then I'll just put a box around it. So we're going to have to take all of this and stick in. So we know that g prime pi over 2. So wherever I see an x, I'm sticking in pi over 2. So we have the tan of pi over 2 over 2. That gets multiplied by 1 over pi over 2. And then we add on the natural log of pi over 2. And that gets multiplied by a half sec squared of pi over 2 over 2. So if we simplify this, we're going to have the tan of pi over 2 divided by 2 is just the tan of pi over 4. That gets multiplied by 1 over pi over 2. So what happens if we 1 over a fraction? Well, we can just flip the bottom fraction around, and that's what it's going to be. So this gets multiplied by 2 over pi. Add on. Can't do anything with the natural log of pi over 2. But now this is where we can start really using our trig identities to help us here. So we have this half, nothing really happens there, it's just a number, sec squared of, and this is going to be the same as this, so we just get pi over 4. So it's going to be a half sec squared pi over 4. Now, sec squared isn't on your calculator. So we can look at our trig values and see what sec squared is equal to see if that helps. So if we go back to the tables, we have that the sec, or the secant, of a is equal to 1 over the cosine of a. So what happens if we rewrite it like that? So if we take this and equal it to, so just this value right here, and say that's going to be, well, sec squared, even though the formula says sec of a is equal to 1 over the cosine of a, sec squared goes to 1 over the cosine of a. So this goes to 1 over the cosine squared, sorry, it goes to cosine squared of pi over 4. So what is the cosine of pi over 4? Because whatever that is, we can just square it. Go back here, cosine, pi over 4 is here, so the cosine of pi over 4 is 1 over root 2. So it's going to be 1 over root 2 squared. So this is equal to 1 over square root of 2, sorry, the whole thing squared, which is equal to 1 over 2. As we said before, just like this part right here, with this part right here, what happens when we have 1 over a fraction? Well, we can just flip that bottom fraction. So if we flip the bottom fraction, we're going to get 2 over 1, which is just equal to 2. And now you can see this question sort of gets blown right open. Also, we have, so just to get the arrows going, this 2 is going to replace this bit right here. Nothing happens to the natural log of pi over 2. Now we can take a look at what happens at the tan of pi over 4. So if we go here, we can see the tan pi over 4 is just 1. So if you go back, this equals 1, that equals 2, and now we can just start filling it out. So this is equal to the tan, 1 multiplied by 2 over pi plus the natural log pi over 2. And here we just have a half times 2, so we just get 1 again. So this whole thing is just equal to 2 over pi plus the natural log of pi over 2. This is why it's important to know the chain rule. Without this, you can't do this question. This is one of the trickier ones in it because you have this tan of x over 2, which then goes to 1 over, or sec squared, which then you have to change to 1 over cosine squared, which then you just get 2 out of when you plug pi over 2 into it. So that's as tricky as the chain rule kind of gets. But that's well doable because you can just repeat questions like this over and over again and it gets much easier. So we'll go back to the sheet and just keep doing a few more. So we have five x squared plus 3 brackets 4. So find the derivative of the outer function first of all. Well, that's just going to be 4 times whatever's inside it cubed. What's the derivative of 5x squared plus 3? Well, it's just 10x. So this is going to be 40x multiplied by 5x squared plus 3 cubed. Next one. Step 1, rewrite this. Square root, how can we rewrite that? Well, it's going to be minus 2x squared plus 1 to the power of a half. And we'll change the colours around just so you can see it a bit more clearly. Same rules apply. So what's the derivative of the outer function? Well, the half comes to the front. A half minus 1 goes to minus 1 over 2. The inner function stays the same. What's the derivative of the inner function? Well, minus 2x squared plus 1 just goes to minus 4x. Multiply everything out, we get minus 4x over 2 multiplied by minus 2x squared plus 1 to the minus half, which is just minus 2x times minus 2x squared plus 1 to the minus a half. You can simplify that if you want, so we just get minus 2x all over minus 2x squared plus 1, find the square root of that. So we're going to just do the last two questions then, and then leave it off with after the chain rule. So, as always, step 1, rewrite this. Well, this is going to be equal to minus 2x to the 4 plus 5. What is the cubed root as a fraction? Well, it's going to be to the power of 1/3. And now we just follow the same steps. So, bring the third to the front. We have a third times what's inside of it, minus 2x to the 4 plus 5. A third minus 1 is minus 2/3. So now we can keep going. So now we have the derivative of the inner function. So this gets multiplied by minus 8x cubed. Multiply this out, we have minus 8x cubed divided by 3, multiplied by minus 2x to the 4 plus 5 to the minus 2 over 3. And if we simplify this, what we get is minus 8x cubed divided by 3. And this whole thing is divided by the cubed root of minus 2x to the 4 plus 5 squared. This 2 comes from this bit right here. This 3 comes from right here. And because it's negative, it goes as a fraction. Final part then. As always, just rewrite this simpler. Minus x to the 4 minus 3 bracket bracket minus 2. Same steps as always. Minus 2 goes to the front. Leave what's on the inside. Minus 2 minus 1 is minus 3. Minus x to the 4 minus 3. What's the derivative of the blue part or the inner function? Well, that's going to be multiplied by minus 4x cubed. So then we get 8x cubed multiplied by minus x4 minus 3 to the minus 3. So this is going to be 8x cubed divided by minus x to the 4 minus 3 cubed. No need to multiply anything out. We can just leave it at that. So I hope this sort of run through just sort of helps. As always, any questions, just let me know. But for the chain rule, we're just going to evaluate both the inner and the outer function, multiply everything but the derivative of the inner function. Same as always.